Hello guys, welcome to another lecture in this course. In this video, we shall be continuing on unsupervised learning algorithms, and in this lecture, we shall be looking into hierarchical clustering. So hierarchical clustering is an unsupervised machine learning algorithm that groups data points into clusters based on their similarities. The algorithm works by creating a hierarchical of clusters, starting with each data point as its own cluster and then merging clusters that are similar to each other. There are two main types of hierarchical clustering: agglomerative and divisive. Agglomerative hierarchical clustering starts with each data point as its own cluster and then merges clusters until there is only one cluster left. Divisive hierarchical clustering starts with all data points in one cluster and then divides clusters until each data point is in its own cluster. Let us take a look into dendrogram and linkages. So for example, here we are start by importing our numpy since we need to play along with numbers. Then let us call our scipy. Since in scipy we have a module called cluster, so the scipy library will take the module cluster, and also inside the cluster module we have a hierarchical class. So we need to import the dendrogram and linkages. So what we need to do is to zip our x and y data, the data that we have been using in our previous video, this data here, the x and y data. This is the x and the y data. So what we need to do here now, so we are just zipping the data. So we are calling created random data above here and we are zipping it. Now we need to create the matrix linkage here. So we are just saying that we are creating a variable here, linkage underscore matrix. Then we call our function here, linkage. Then we are passing on our data as our parameter, which we have zipped, and the method we are saying word. So now we need to plot the dendrogram. So to plot the dendrogram, what we need to do now, we pass on our linkage matrix, which is having our data. Then we just click show here. So this is the dendrogram. As you can see, this is how the data looks like. This is how the data representation of a dendrogram. So here we call our random data, then we create the linkage matrix, which is a matrix that stores the distance between all pairs of clusters. So we can actually see the distance between all pairs of clusters. And finally, the dendrogram is plotted, which is a tree-like diagram that shows the hierarchical of clusters. And the linkage function in the scipy.cluster hierarchical library takes the data and the linkage method as input and retains the linkage matrix. So the word linkage method that we have put in place as our parameter is a popular linkage method that minimizes the within cluster variances. So in short, we are just saying the dendrogram function in the scipy in the scipy cluster hierarchical library, it takes the linkage as input and plot the dendrogram that we are seeing here. Okay, so this is how we also cluster the data in any hierarchical form, by looking at the data which is close to each other and form a hierarchical clustering that we see. Okay then, so now let us take a look into another method called agglomerative clustering. Here in this case here, we are just saying that since we are manipulating numbers, and in these numbers we are calling our cluster module and from our scikit-learn library, and we need to import this function agglomerative clustering. So what we need to do is to create the clustering model here. So we have to store it here, then and this model we need to cluster it into two categories or two groups, and the linkage we are going to use the word. Okay, the linkage equal to word. So fit, now we need to fit the model to the data. So model, our data, our model here, which we have created, dot fit underscore predict our data which we have zipped on X and Y. And now we need to get the cluster labels. So to get the cluster label, we just take our model and the labels dot underscore. Then we just plot our scatter plot here. And where see our parameter, we just put our labels here, X and Y. So let us visualize our plot. This is the data, and it's the same data that we have obtained above. Here it is similar. So it is similar with this data set that we have obtained here. It is similar with this. So it is another concept of unsupervised machine learning that you can use to analyze your data. And we can see that the agglomerative clustering function here in the scikit-learn cluster library, it takes the number of clusters and the linkage method as input and return the cluster model. And the fit method of the clustering model is just fitting the model of the data. While this label attribute of the clustering model, it just retain the cluster labels. So that is how we cluster. For example, here now, fit the model to the data. For example, we want to check the prediction. We can actually see that we have 0, 0, 1, 1, 1 to see the prediction of the data that we are having. And we can actually see that the output model.fit predict data is an array of cluster labels. In this case, the array has 10 elements, and each element is a cluster label. And the cluster label are integers, and they range from 0 to 2 only. And this the meaning of the cluster labels depends on the clustering algorithm that is used. And in this case now, the clustering algorithm is agglomerative hierarchical clustering with the word linkage method. This means that the clusters are formed by merging the clusters that are most similar to each other. We just merge the clusters which are nearby and they are similar to each other. And same goes here if we are to generate a random number. Those are the numbers that we created, X and Y. So if you are generating random numbers and we put a number of clusters, we need 3 using the same method of linkage here, which is equals to 1. And we check our model here, we fit our model. And here also, we pass our parameter of our class label here, our cluster labels here, and we visualize the cluster of the data that we are having in our scatter plot. So if we are to run the plot here, we can actually see by here we want to label the clusters. That's why we are actually seeing that for I in range length, we have 10 data here. So plot dot annotate a string label I. So we just label if it's 0, it's 0. If it's 1, because here we have confirmed that we have 10 data. We have 10 elements in our data. We have 10 elements there. So 0, 0, and 1, and we need to see what's going on. So in this case, in random numbers, now we are saying we need 3 clustering number of clusters is 3. So we should see 3 groups, which is 1, 1, 0, 1, and 2. These are 3 groups, and the labels are seen as follows. So in short, it's just the output of this code is a scatter plot of the data points, in which each cluster represented by a different color and labeled with the cluster number. So similar data, they are only clustered together. The data which are similar, they are grouped together, as you can see. Then you know that, okay, so this one, it is related with this one. So this is what we call hierarchical clustering. I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye-bye.